minimum? Okay, calculus can be find a local maximum or minimum. Okay, calculus is find local maximum, minimum is the turning point and point of inflection, but these are often not the actual maximum and minimum values of a function. As I show you like before. Okay, so the graph can look like this. Okay, that's the actual maximum, that's the actually minimum. Okay, and here is the local maximum, here is the local minimum. Okay, so when you're trying to see whether the point is a local or absolute maximum or minimum, you need to use the graph to help you. Okay, you need the graph to help you. Or say in other words, the endpoints normally form the maximum or the minimum point. Okay, the endpoints is normally formed with the maximum or the minimum point. So what you need to compare with is the local maximum and the endpoints. Okay, see which one is higher and which one is lower. So the higher one should be the absolute maximum. Okay, the higher one should be absolute maximum. I will show you an example later. Wait. Just come back a little bit from last lesson. Okay, for last lesson, we have, okay, I'm not sure if you remember that one. X cubed minus 12x plus 10, okay? We want to solve for that. I forgot that here. Okay. Part C is asking you to find the values of x and y for which v equals to 10 centimeter cube. Okay, 10 centimeter cube. Okay, can we see all the things we have is in meters cube? Okay, I make a mistake last week. That's 24 meters cube, and that is in meters cube. Okay, that is in meters cube. So what you have here is not 10. Okay, it's actually 10 times. Okay, centimeter cube. Want to convert to meters cube. Okay. Is 10 to the power of, like it's 100. 1 meter equals to 100 centimeter, 100 centimeter. And then it's talking about the volume. So it's to the power of 3. That's 10 to the power of 5. Okay, 10 to the power of 5. 1 meter cube equals to 10 to the power of 5 centimeter cube. Wait, not 5, 6. 2 times 3 is 6. Okay, 10 to the power of 6 centimeter cube. Then that will equals to 10 to the power of negative 6. Okay, it's 10 times 10 to the power of negative 6. Because 1 centimeter cube will equals to 10 to the power of negative 6 meters cube. Okay, it's going to the smaller values. And you will just solve that by CAS. Okay, solve that by CAS. Okay, just solve that by CAS. I'm not going to show you like how to calculate that. You can work that out. And remember to find y value. Okay, what you solve out by CAS is the x value. Then you are asking to solve out the y values. Okay. Find x and then sub that back into the y equals to how many x and find the y values. Okay, that's this example. Okay, let's have a look at example 3. I have explained to you what is absolute maximum, what is the absolute minimum. Let's say let function f domain is negative 3 to 4. Fx equals to this function. find the absolute maximum and the absolute minimum for this function. Okay, the absolute maximum is either one of the endpoints or it can be the local maximum. The absolute minimum is either one of the endpoints or is the local minimum. Okay, it's either the endpoints or the minimum, local minimum, the turning point. Okay, so what you need to work out is the local maximum minimum and work out the two endpoints value. Okay, the two endpoints value. So let's say we have f dash x is 6x squared minus 8x minus 22. And I want that to be 0. So for the stationary points, okay, so for the stationary points, that's 3x squared minus 4x minus 11 equals to 0. Okay. B squared, discriminant is b squared minus 4 times a times c. That's 33 times 4. That equals to, okay, 148. And if 148 divided by 6, divided by 4, what's that? So x will equals to minus b plus minus square root of 148 divided by 2a, which is 6. Okay, minus b plus minus square root b squared minus 4ac over 2a. Okay, x equals to 4 plus minus 2 root 37 over 3. Over 6. And x equals to 2 plus minus root 37 over 3. Three x squared minus 4x minus 11 equals to 0. Okay, I'll use CAS to work out this value. Okay, I'll use CAS to work out this value. Okay, if we have a calculator, let's save this value. Two x cubed minus 4x squared minus 22x plus 24, and save for that. Control VAR fx, and let's solve menu 3.1. I will derive fx. I want to make that equals to 0 and a comma x, and remember to give that your domain is negative 3.5. Okay, 3.5 is 7 over 2, negative 7 over 2, smaller equals to x, smaller equals to 4. and I have solved out this two value. Okay, I have solved out this two value, and I want to know the y value. Not only interested in the x value, I'm also interested in the y value. So for the y value, I can have f bracket. I have this value. Enter. So I have that, and I'll have f of that value. I will have that. Okay, and I'm also interested in the like endpoints, the two endpoints, and f3 negative 3.5. I will have that, and f bracket positive 4. I will have that. Let's just make that equals to decimals, and that equals to decimals. Okay, we have that. Okay, we have those four values. The top two are the endpoints, and the bottom two are the local maximum or minimum points. And we can see that will be the local maximum, that will be the local minimum, maximum, minimum, and those two are the endpoints. But like say, we'll use the local maximum to compare with those two. Okay, it's larger than both of them. Then this will be the local maximum and also the absolute maximum. Okay, I'll use the local maximum to compare with the two endpoints. It's greater than the two endpoints, which means it's the absolute highest value. There's the absolute and also the local maximum. And that's the local minimum value. Okay, that's the local minimum. If I use that one to compare with those two numbers, this one is more negative. Then this is the local minimum, and this is the absolute minimum. Okay, so absolute minimum and absolute maximum. Okay, top one is the absolute minimum, the bottom one is the absolute minimum, maximum. Absolute minimum, absolute maximum. So negative 33.75. And absolute maximum is 41.49. Okay, just 2 dp. 2 decimal places. So the absolute maximum, absolute minimum can only exist is at a local maximum minimum or is the endpoints. Okay, just need to compare those two places. It's the local turning point, like local maximum minimum, and also the two endpoints. So 4 points you need to work out. Okay, example 4. From a square piece of metal of side length of 2, 4 squares are removed as shown in the diagram. So the diagram will be looks like this. 4 squares are cut from each corner. So it looks like that. That's 2 meters, 2 meters. Okay, and then X is cut here. If the height of the box must be at most 0.3. So your X needs to be in between this. Okay, that's the domain for your X. So X can't be less than 0, so always greater than 0, but the height at most 0.3. So you have 0.3 greater or equals to X. What will be the maximum volume of this box? Okay, what will be the maximum volume of this box? So we have done this type of questions a lot. So the base of this box will be this red thing here, and it's also a square as well. So it's 2 minus 2x, 2 minus 2x. Okay, so volume will gives me 2 minus 2x squared, and also time with x. Okay, the base times height. Okay, when you form this box, the height is x. And that v equals to 4x squared minus 8x plus 4, and then time with x. V will equal to 4x cubed minus 8x squared plus 4x. Or I can take 4x as a common factor. I have x squared minus 2x plus 1. V equals to 4x, x minus 1 squared. Okay, I can also have that. It's either in this form or in a fully factorized form. Okay, now I want to find the maximum volume. Okay, I want to find the maximum volume. Let's first sketch the Vx graph. Okay, let's sketch this Vx graph. So that's the V, that's the X. I will have 0, 0 here, and I have 1, 0. 1, 0 will be a turning point. Okay, 1, 0 will be a turning point. And the leading term is positive, so I will have that. Okay, so that's the rough shape of this graph. Okay, that's the rough shape of this graph. That's 1, 0. That's 0, 0. But you can only have 0.3. Okay, 0.3 at the maximum. So you want to see where is the 0.3. So find the 0.3. You need to work out where is this turning point first. Okay, where is this turning point? Whether the 0.3 is to the left of this turning point or to the right of this turning point. Okay, if to the left of this turning point, then the maximum value will be the 0.3. If it's to the right of this turning point, then the turning point will be the maximum volume. Okay, the turning point will be the highest point. So you want to see where is this 0.3. So let's work out this turning point first. To find this turning point, you want to find dv dx first. dv dx equals to 12x squared minus 16x and plus 4. And you want to solve that equals to 0. If you solve that equals to 0, it's 3x squared minus 4x plus 1 equals to 0. X minus 1, 3x minus 1 equals to 0. Okay. Minus 3x minus 1x minus 4x and plus 1. So x equals to 1 or x equals to 1 on 3. Okay, x equals to 1 is the minimum turning point, which is here. Okay, that is 1. Then this point will be 1 on 3. Okay, I don't need to know what is the y value. I just need to know what is the x value. So the x value is a third. Okay, the turning point gives me a third. Then the maximum value I can take is 0.3. Do you think 0.3 is to the left or to the right of this point? Left. A third is 0.3333, right? So 0.3 will be here. That is 0.3. That is the last point you can take. And here is an open circle. And that is the graph. Okay, so the turning point is actually not included in this graph. Okay, the turning point is actually go outside of this graph. So for your domain, it's a strictly increasing graph from 0 to 0.3, which the turning point is not included in this graph. So what will give you the maximum point? 0.3 will give you the maximum point. So when x equals to 0.3, V max will equals to 4 times 0.3 times 0.3 minus 0.7 to the power of 2. So it's 1.2 times 49, 0.49. Okay, so it's 0.49. That equals to 0.588 meter cube. Okay, that is the maximum you can take. So the important thing for this question will be make sure where is the turning point and see your endpoints is to the left of the turning point or to the right of the turning point. If it's to the left, the turning point, to the left, if the turning point is not included, then the endpoints will give you the maximum value. If it's to the right of the turning point is included, then the turning point will be the maximum value. Okay, that's example 4. Okay, next one. Next one is the application of differentiation of kinematics. One formula I want you to write down is average speed and average velocity. Okay, average velocity will be x2 minus x1 over t2 minus t1. So average velocity is not adding the velocity together and divide by how many velocity you have. It must be the change in displacement. Okay, x2 means the displacement for time 2, and minus x1 what will be the initial displacement at the beginning. You subtract them will means the displacement change between time 1 and time 2. So the change in displacement divided by the change of time will give you the average velocity. And average speed will be the change. So I'll not say the change. Will be the total distance traveled divided by the total time taken. So what's the difference between the first one and the second one? So the displacement, okay, the displacement is only see the final position and the initial position. Say I have 0 here, that's the original point, and I start from this original point. I go left for 3 units, next 3 units, and then I go right to 3 units, and then I go here, that's 1, and then I will keep going to that side, give me a 5. Okay, so that's my travel path. I start from this origin, and I go to the left, and then I go to the right, and then go left again, and I go to the right, okay, with those units. So the total displacement for this particle, just see the initial position 0, the final position 5 is positive 5. Okay, the displacement is positive 5 to the right of the initial point for 5 units. And the distance traveled. Distance travel will be, okay, that's a 3, go 3, back to 3, that's a 6, and that's a 2, and from 1 to 5, that's a 4. So I will use 3 plus 6 plus 2 plus 4, that gives me 15. Okay, 15 is the total distance traveled. Let's say if this particle from here to here takes 5 seconds. Okay, takes 5 seconds. Average speed will equal to 15 over 5. That equals to 3 meters per second. And average velocity equals to 5 over 5. Equals to positive 1 meters per second. That is the average velocity. Okay. So velocity is found by using the x, okay, x1 and x2 values. Okay, that's how you find that. And then similarly, if you're trying to find average acceleration, okay, we suppose something average acceleration. If acceleration is keep changing, okay, from time to time, the average acceleration will be the change in velocity over the change in time. Okay, change in velocity over the change in time. And we'll have instantaneous acceleration. That will be the second, like you derive vt. Okay, you derive xt, that will give you vt graph. If you derive vt graph, that will give you at graph. Okay, you're going to do differentiation and differentiation. If you have xt graph, you differentiate once, that will give you the vt graph. If you derive vt graph, that will give you the at graph. Okay, acceleration may be positive, negative, or zero. So zero acceleration means the particle is moving at a constant velocity. Okay, if the acceleration is zero, means it's not accelerated at all. So it's keep doing this uniform speed. Okay, uniform velocity. The velocity is not changing. So note that direction of motion and acceleration need to be coincide. So if you say this is the positive direction for velocity, then this should be the positive acceleration as well. Okay, you can't say that's the positive acceleration, that's the positive velocity, and that's the positive direction. You can't do that. So all the positive needs to decide to one side. So right hand side is the positive distance, is the positive velocity, and it's positive acceleration. So all needs to be the same side. If a particle has a positive velocity, indicating it moving to the right, but a negative acceleration indicates that the particle is slowing down. Okay, a negative acceleration doesn't mean your particle is moving to the other direction. Actually, it means you're slowing your particles down. Okay, if I'm traveling to that side, but my acceleration is that side, you can say as like I'm pulling this particle to that side. Therefore, your particle will slow down. Okay. But if, say, I have a positive direction of velocity and positive direction of acceleration, which means your particle is speeding up. Okay, you just see whether your acceleration and your the direction of your acceleration and the direction of your velocity is the same or not. If it's the same direction, then the particle is speeding up. If it's different direction, then your particle is slowing down. Okay, so that's for acceleration. Although a particle may be instantaneously at rest, its acceleration at that instance do not need to be zero. Okay. Say what I say is if a particle is rest at instance, okay, at that moment is zero velocity, doesn't mean your acceleration is zero. So you can have a zero velocity, but you still have an acceleration at that time. Okay. If acceleration has the same sign as the velocity, then the particle is speeding up. If the sign is opposite, the particle is slowing down. The most commonly used units for acceleration is centimeter per second square or meters per second square. I'll say the common used one is the meters per second square, not actually the centimeter one. Okay, the most common used one is the meters per second square. Okay, example 1. A particle moves in a straight line so that its position x centimeters relative to O at time t seconds is given by that. Okay, you know your xt graph, then you can find your vt graph, you can find your at graph. Find the initial position. The initial position must be x0. x0 equals to 6 meters, okay, to the right of 6. Find its position at t equals to 4. If you want to know t equals to 4, you want to know x4. So 4 squared minus 7 times 4 plus 6. That equals to 16 minus 28 plus 6. That equals to negative 6 meters. It's to the left of the particle of 6 units. To the left of the to the left of the original for 6 units. Actually, I'm not using the meters as the unit. There's not say centimeters. Okay, centimeter, not meters. Find the initial velocity. If I want to find the initial velocity, that must be the derivative for the xt first to find the vt graph. Then it's 2t minus 7. 2t minus 7. Then v0 must be negative 7 centimeters per second. At the beginning, the particle is moving to the left of 7 centimeters per second. So you find vt first and you put 0 in. when does its velocity equals to 0 and what is position at that time? So you want Vt equals to 0. Therefore, you need 2t minus 7 to be 0. T equals to 7 over 2. Okay, t equals to 7 over 2. At that instant, your velocity equals to 0. What is position at that time? You want to find x 7 over 2. Okay, 7 over 2 is 49 over 4 minus 7 times that is 49 over 2 plus 6. 6. 6 is 24 over 4. Okay, plus 6. So that's a 98 over 4. That equals to minus 25 over 4. Okay, if you can calculate that, 49 plus 24 gives you 73. 98 minus 73 gives you 25. It's a minus 25 centimeters. It's to the left of the origin of 25 over 4 centimeters. Okay, to the left of the origin, 25 over 4 centimeters. Next two is the most important part. Find the average velocity for the first 4 seconds. First 4 seconds is 0 to 4 seconds. Okay, t belongs to 0 to 4 seconds. Average velocity will be AVG velocity will equals to x4 minus x0, the change of the position. Okay, the change of the position. What's the final position? What's the initial position? The change of them. Divide by 4 minus 0. Okay, divide by the change in time. That equals to, okay, x4 is negative 6. Okay, you have it in part A, minus x0, which is 6. Divide by 4, minus 3 centimeter per second. The next one will be the difficult one. The next one says determines average speed for the first 4 seconds. So average speed will be, you need to know the distance traveled for the first 4 seconds. Okay, the distance traveled by this particle for the first 4 seconds. But xt graph doesn't give you speed. Okay, xt graph only gives you displacement. You don't know the distance from the xt graph. So what you need to find is the vt graph. Okay, let's sketch the vt graph first. You know vt graph is 2t minus 7. Let's sketch vt graph. I want to know vt graph. Okay. So 0 minus 7, and I will know that's a 3.5, 0. Okay. So I have this graph. That's 0, negative 7, and here is 7 over 2, 0. That's the vt graph. Okay, let's have a look. Where is from 0 seconds to 4 seconds? Okay, that's 3.5 and 4 seconds will be here. So that will be the 4 seconds, the red point. Let's say 4, what is the velocity? You put 4 in, the velocity 1. Okay, Vt equals to 2t minus 7. You put 4 in, you have 1. So that height is 1. Okay, now I'll tell you the area under the curve for the velocity function will give you the distance. Okay, will give you the distance. Okay, so can you see some area? Let's say that area is under the curve. That area is above the curve. Let's use the black. Okay, that area is above the curve. That's the area bound by 0 to 4 seconds. Okay, 0 to 4 seconds. From 0 to 4, that's the area under the curve between the x-axis and the curve itself. So that gives me 7. So that area equals to a half times 7 over 2 times 7. That's 49 over 4. And that area gives me a half times 1. That gives me a quarter. Okay, that equals to a quarter. If you add between those two areas, that will give you the distance. Okay, distance is regardless of the sign. Don't worry about whether the curve is under the graph, under the x-axis or above the x-axis. You just add them. 49 over 4, add 1 on 4, that gives you 50 over 4, that is a 25 over 2. That's the distance between the time 0 to 4 seconds. If you want to know the displacement, you will take the sign into account. The a quarter is positive a quarter, but the area under the curve will become negative of that. That gives you negative 48 over 4, that is negative 12. Okay, that is from 0 to 4 as well. Can you see that is the displacement? Okay, that is the displacement. We have the displacement before here, which is negative 12. Okay, that distance is negative 12. So you will have negative 12 as the displacement if you take the sign into account. But if you're not thinking about the sign, you treat them all positive, then the curve area under the curve would add them, that will give you the distance. Okay, that will give you the distance. So the average speed equals to the change in distance, which will be 25 over 2 divided by the change in time, which is 4. That gives me 25 over 8 centimeter per second. Okay, that is the average speed. To find average speed, you need to find the total distance. The displacement function will not give you the total distance. So how do you find total distance? Total distance is found by using the VT graph. If you treat the area as signed area, that will give you the displacement. If you treat the area as just like true, like positive area, if you add them, that will give you the distance. Okay, so VT graph is very helpful. That will give you the displacement and also the distance. Okay, you find displacement and distance by using the VT graph. That's this example. And have a look at the next one. A point moves along a straight line so that its distance x centimeters from point O t seconds is given by xt equals to that. At what time and in what position the point have velocity equals to 0. So let's find our vt first. Vt will equals to x dash t. That will give you 3t squared minus 12t plus 9. Okay, and let's find AT graph first. And then AT equals to V dash t. Derive the VT graph. That gives you 6t minus 12. So I want want to know the velocity equals to 0. The velocity equals to 0. So you want to have that equals to 0. Then you have t squared minus 4t plus 3 equals to 0. T minus 1 and t minus 3 equals to 0. T will equals to 1 or t will equals to 3. So at 1 second and 3 seconds, this particle will have zero velocity. And where is the particle? You will find the position by using the xt graph. x1 equals to 1 minus 6 plus 9, that equals to 4 centimeters. And x3 equals to 3 cubed is 27 minus 3 times 3 is 9, 6 times 9, 54, plus 27, that equals to 0. Okay, it's at the position, at the origin. Okay, at the origin. So at 1 second, you will be at 4 centimeters to the right. At 3 seconds, you just pass through the origin. At those two moments, you have zero velocity. Okay, at those two moments, you have zero velocity. Find its acceleration at those instants. Okay, acceleration. So you found acceleration of 1, and you want to find acceleration as 3. So a1 equals to 6 times 1 minus 12 will be minus 6. Okay, minus 6 centimeter per second squared. A3 equals to 6 times 3 minus 12 is positive 6 centimeter per second squared. Next one is find its velocity when the acceleration is 0. Find the velocity when the acceleration is 0. So when you have at equals to 0, which is 6t minus 12 equals to 0, t will equals to 2. Okay, t equals to 2. At t equals to 2, your acceleration is 0. Then you want to find the velocity at that time. So you want to find v2. You want to find v2. So vt is 3t squared minus 12t plus 9. 3 times 2 squared minus 12t plus 9. That's 3t squared minus 12 times t plus 9. 12 minus 24 plus 9. That's minus 3 centimeter per second. Okay, minus 3 centimeter per second. So those two questions are really basic questions. You just need to find VT and AT graph, and by using what it tells you, you make that equals to 0, solve out the t value, and substitute back. Okay, substitute back. Okay, example 3. A particle moves in a straight line so that the position x centimeters relate to the origin O and t seconds is given by this. Okay, find the initial position, velocity, and acceleration. Okay, initial position, velocity, and acceleration. So let's find our Vt first. Vt equals to 3t squared minus 12t, and At equals to 6t minus 12. Okay, 6t minus 12. So x0 equals to 5 centimeters. V0 equals to 0 centimeters. And A0 equals to minus 12 centimeter per second squared. It's asking me to describe its motion. Okay, to describe its motion, where does particle start? Okay, this particle starts at origin with no velocity. And the acceleration is negative, the particle will move to the left. Okay, can you think about that? No, start at 5 centimeters. Okay, 5 centimeters to the right of origin. Okay, start at 5 centimeters to the right of the origin. There's no velocity initially, and the acceleration is drag the particle to the left. Then the next second, the particle will move to the left because there's a negative acceleration. Okay, because there's a negative acceleration, the particle will move to the left. Okay, I'll just 1 minute to finish up that. So instantaneous at rest is Vt equals to 0. Okay, it's Vt equals to 0. So you want that equals to 0. That's 3t, t minus 4 equals to 0. T equals to 0 or t equals to 4. That 2 seconds you have instantaneous at rest. Determines position and acceleration at those times. So you want to know xt, x0 equals to 5 and a0 equals to negative 12. And you want to know what is x4 gives you, and you want to know what is a4 gives you. Okay, a4 gives you 6 times 4 minus 12. That is 12 centimeter per second square. And x4 will give you 4 cubed minus 6 times 16 plus 5. That's minus 27 centimeters. Okay, so you have 2 group of the answers here. Okay, I just finish up this and we'll have revision from next lesson.